Hello everybody, we're getting ready to do SAT Math Level 2 preparation for Chapter 6, which is Triangle Trigonometry Part 2 for this, and you will have 12 points on your notebook guide or into your notebooks themselves, and then 18 points on your class worksheet. Have those out. Name, date, period, students in my classroom, due date for onliners, homeschoolers. Let's go right into page 1 here of part 2 of chapter 6. You also learned in geometry that knowing the measures of two sides and a non-included angle of one triangle are congruent to those of another triangle, SSA, side-side angle, does not guarantee congruence of the triangles. So knowing that the measures of two sides and non-included are congruent in those of another triangle does not guarantee congruence. This SSA case is called the ambiguous case because there are several possible outcomes depending on the values of the measures. Case 1 in the figure here, we have this situation here with this triangle here. Angle A, the given angle is obtuse. This is obviously an obtuse angle. The side with length A, so this side over here, is the side opposite angle A. It must be one of the given sides. The other given side in the figure is AC. So AC here, and let's see, AC would be over here. This here AC would be side length AC here. And it has length B, so here's our length B here for that. In the figure, angle A is obtuse. The figure shows clearly that there is no triangle unless A is larger than B. So A, the length of A, has to be longer than B. Otherwise, you're going to have a side that's just hanging, somewhere like this. In this case, the law of sines can be used first to find the measure of angle B. So we need to find here the measure of angle B. Subtract the measures of the two known angles to get the measure of angle C. So once we know A and B, we can find angle C. Then use the law of sines again to find the length here of this side here of length of C. Okay, so let's go into an example that goes through that progress here. Solving triangle ABC. So a measure of angle A is 125. This is 125. The measure of A is 10, and then the measure of B down here would be 8. So we need to solve this triangle. By the law of sines, sine 125 over 10 will equal sine B over 8. So we know 125 over 10 is proportional to the sine of angle B over 8 in this case here. Therefore, sine B will equal 8 sine 125 over 10, which comes out to 0.6553, and the measure of angle B in this case here will come out, when you take the inverse of that, will come out to being 40.94 degrees. So the measure of angle C, by using our 180 rule of triangles, would be 180 minus 125 minus 40.94, and that comes out to 14.06 degrees. By the law of sines one more time, sine 125 over 10 will equal sine 14.06 over C. So C will equal, in this case here, C will equal 10 sine 14.06 over sine 125, which comes out to 2.96 now for the measure of this side here. So we got to use the law of sines twice when we have a situation like this to completely solve this triangle, coming up with all the side lengths and the angle measures. Case 2, that was case 1. If angle A is right angle, so now we're dealing with a right angle here, then A is the length of the hypotenuse, and the measure of B, the measure of angle B over here, will be the inverse sine of B over A. I mean, that's kind of a shortcut there. Using the fact that the sum of the angles of a triangle is 180, to find the measure of the third angle and use the Pythagorean theorem to find C, to find the length of C, the length of the third side. This case is not likely to be seen on level 2 math subject tests, but it is included here for completeness and for review of your Pythagorean usage, solving triangles. So with an example, solving ABC of measure A equals 90, A equals 7, so we know this equals 7, and then B equals 5. So we need to find the measure of C here. And angles of B and C as well. So sine B, in this case here, sine B, the sine of here will be 5 over 7. So the measure of angle B will equal the 45.58 when we take the inverse of that. And then the measure of angle C by using elimination here will be 44.42 degrees. And then the length of C here, length of this side here, will be the square root of 49 minus 25, which comes out to about 4.90. Again, by using the Pythagorean theorem, which is always handy. Triangles. Solving ABC of measure A is 90, and A equals 7, B equals 5. We're back to that one again. So sine B over 7, so 45.58. We get 44.2. So again, this is another look at that same triangle. And just as a reminder, this is how you can do it in a quick manner. Time is of the essence on the level 2 SAT. It's only an hour for 50 questions. So it's good that you know your Pythagorean theorem for sure. Okay, case 3 in the figure below. Angle A is an acute, so this is an acute angle at the bottom left, and h equals b sine A is the length h. So here's our height here. H equals b sine A. So it would be b sine A would be the length here of h of the perpendicular from C to AB. So from C to AB here, the length here. There are 4 subcases summarized in this situation. Case 3A, if A is less than H, so if A here is less than H, there is no triangle. So if the length A here is less than the height, there's no triangle, so we have no triangle there. Then solving a triangle ABC of measure A is 50, A is 3, and B is 5. So in this situation here, and this is like you're hanging A here, so we have no triangle in that situation. First calculate H here would be a 5 here. So 3, or B here would be 5 squared equals 3 squared plus H squared. And that comes out to being 3.83. Or you can use the sine function to find that. 5 sine 50 degrees. Since, because we're given A here, since 3 is less than 3.83, there are no triangles. So you can ascertain that. If you come up with figures like that, there is no triangles. Case 3B, if A is greater than B, so if A is greater than B down here, there is one triangle. So side A here, if it is greater than B, there is one triangle. Solve triangle ABC of measure A equals 50, A equals 7, and B equals 5. So we have this situation here. Since 7 is greater than 3.83, so A is 7, B is 5 down here. B is 5 down here. Oh, B is 5. Okay, B is 5 over here. That's 5. And then since 7 is greater than 3.83, there is one triangle. So this would be your side C here is one triangle, and it is obtuse. There is one triangle, so we have an obtuse angle here. Follow the same procedure as in case 1 to solve this triangle. By the law of sine, sine 50 over 7 will equal sine B over 5. So sine B over 5, which is over here, and then to find that angle there. And to find that angle, sine B equals 5 sine 50 over 7 will come out to 0.5472, and then when we take the inverse of that, we get 33.17 degrees for this angle measure here. Calculate the third angle as 180 minus 50 minus 33.17, and we come up with 96.83. By the law of sines again, we can check it by law of sines. Sine 50 over 7 will equal sine 96.83 over c. So when we come up with that, c will equal 9.07. In this case, the triangle is obtuse, yeah. Because of this angle here, it is definitely an obtuse triangle. And we come up with this side length here of c. Case 3c, if a is greater than h, but a is less than b, there are two possible triangles. These are shown as triangle ABC and triangle AB tilde C. In the figures below, here's our situation. Here we have this triangle like this, and then this A can be swept underneath. It can be swept like this here, so that its angle here will be greater than 90 degrees. So you have two possible triangles here. When you have this situation here, when A is greater than H, A is greater than H, but A is less than B, A is less than B, so A is less than the original side length here, A can be swept over and create another triangle here. So you have two possible triangles when you have that kind of situation. So going into an example of this, if triangle ABC is a measure of A equals 50, A equals 4, B equals 5. So since A equals 4 and 3.83 is less than 4 is less than 5, there are two possible sides that have length 4. So this is often called the ambiguous case because there are two non-congruent triangles to solve. ABC and then AB prime C. First, use the law of sines, as in case 3b, sine 50 over 4 equals sine b over 5. So we can go into that. And then so sine b will equal 5 sine 50 over 4, which comes out to 0.9576. There are two angles whose sine is 0.9576. The measure of angle B down here will be 73.24, which is the one you get on your calculator when you take the inverse sine of 0.9576. And the measure of angle B tilde, which would be this measure here, would be 180 minus 73.24 to be 106.76. Here's your reference angle here. You take the measure this way and you get 106.76 there. Since the sum of the angle measures in the triangle is 180, so now you have this measure here, 180 minus 50 minus 73.24. This comes out to being 56.76. And then for this angle here, the measure of angle AC B tilde here will equal 180 minus 50 minus 106.76 will be 23.24 degrees here. So using the law of sines again to find C and C prime down here, here's C, and then here's C prime. So for C, it'd be sine 56.76 over C will equal sine 50 over 4. And then when we work that out, we get C equals 4.37 in this case here. And then with that, solving for a final side here, C prime, doing this again, setting up our proportion here, sine 23.24 over C prime here equals sine 50 over 4, then that will give us 2.06 for the length of C prime down here. To summarize, ABC, this triangle here, measure of A is 50 degrees. Here's your measure A is 50. Measure of angle B would be 73.24. And then the measure of angle ACB up here would be 56.76. A will be 4. B will be 5. And then C will be 4.37. Excuse me. And down here for this triangle here, the triangle AB prime C, the measure of angle A is 50 degrees here. The measure of B prime here will be 106.76. And then the measure of angle ACB prime be 23.24 for this measure up here. And then sides here, A will be 4, B will be 5. Here's your side length here, B, and then C will be 2.06. Will be down here. So that was one of those two triangles. Case 3D. It's not likely but possible that A equals H, in which case there is one right triangle. So here it is, A equals H, so you only have one triangle. The key to remembering these cases is sketching the figures shown, especially in case 3. Given the measures of two sides B and C and the included angle A of a triangle, there is a convenient formula for finding the area of triangle ABC. In the figure below, the altitude to the base of measure C is H equals B sine A. The area of triangle ABC is therefore 1/2 CB sine A. So these are just other ways of calculating areas of right triangles. So here it is here. The area of ABC would be 1/2 CB sine A. That would be another way that you could calculate the area of this triangle. Instead of finding the area of two triangles, you could find the area of this whole triangle by using this formula here. And that'll save you time. Find the area of triangle. Measure A is 62 degrees, B is 6, and then C is 12. C down here will be 12. And A equals H here. So again, using the formula we just used, to find the area of triangle ABC, it'd be 1/2 12 times 6 times sine 62 degrees here. And you'll come out with 31.79 square units. So that'd be a fast case of calculating this area. And that is your section chapter 6, SAT Math Level 2 Prep, Part 2, Animated PowerPoint Math Video at AOL.com for course materials and questions. Thank you.